Yeah, thank you. So this one's going to be a bit different. We've already had some amazing talks about all the amazing tools out there. This presentation is going to be a bit more focused on what we can do with these tools. So imagine you are an engineer in the early 60s, and your president has just announced something pretty crazy, that we're going to send humans to the moon. They need to launch from Earth, launch into space, travel to the moon, orbit around the moon, exit the orbit, land on the face of the moon, walk around a bit, get back in, go back up to lunar orbit, come back to Earth orbit, and come home safely. Okay, cool. How are we going to do this? The problem of navigating through space is incredibly difficult, so they need to make new technology for this. You need to make the Apollo Lunar Gateway, the Apollo guidance in that computer. So they tried to do this, and there are a lot of issues. How can you make something powerful enough to be able to do these calculations, but also be reliable enough to work in space when human life's aligned? And to do this, they needed to use absolutely new technology. Chips. So these are really the first application of chips in a real use case. And of course, since then, we all know that chips are absolutely everywhere. Now, of course, the space industry has also changed in this time. So going from these early days of very government-focused, it's now incredibly commercial. Billions are made every year in space. And there are over 10,000 satellites in space above our orbit, above our heads at the moment. But some things haven't changed. It's still very hard to build hardware for space. It's expensive to launch stuff to space, which means size matters, and how much capability you can fit into small volume really matters. Once you launch something to space, a human will never touch this again in most cases, which means that it needs to be able to work reliably for very long times in a very extreme environment. And development is still very slow. It's very hardware-focused and very fragile. So you want to build a system like this, a satellite electronic system, you need to use chips. You can use some space chips, or you can maybe use some commercial automotive chips. These are the options you have. The space chips are very expensive and often very poor performance, and the commercial chips lack the reliability, and they don't have the features needed for space, sorry. So the question is there another option? And the answer is yes. So at SPHERICAL, my company, we take a different approach. Rather than trying to build these space systems with generic microchips, we go one level deeper, and we make our own microchips. And as you may guess, we use open source tools extensively for this. So why do we do this? Because the systems that we can make are 5 times smaller, 5 times more reliable, and importantly, a lot more software configurable so they can adapt to the needs of the space system. So we designed our first chip using open source tools. So you can see here it's for power management. It's a gate driver for a gallium nitride FETs. You can see the layout we made with K-layout. Of course, we manufactured it. You can see the chip here. But we want to go a bit further than just manufacturing it. So we tested it in radiation, threw some protons at it to prove that it works in a radiation environment. Then we built it into a system, a power management system. Then we did vibration testing to prove that this will survive the launch load on a rocket. We did thermal vacuum testing to prove that it can work in a vacuum space with the variations in temperature that you often see. Then we integrated it onto a satellite. And of course, the next step is launch to space next year. So this has shown that we can use the open source tools to create a chip and get it ready for space and create a commercial product for it. So what do we do at SPHERICAL? We focus on these areas. So we make power management systems, motor control systems, propulsion systems, and actuator control systems, all using the technology of analog, mixed signal, open source EDA tools. So here we use the standard set of open source tools. So X-Scheme for schematics, K-layout for layout, all very familiar to most of you. We do use a little bit of commercial tools, mainly for sign-off. So we want to do DRC, LVS before we do sign-off. We have to use these tools, but we try as much as possible to use the open source tools. Don't want to lean too heavily on the geopolitical side, but for some people in Europe, the fact that we can design our chips in the Netherlands, manufacture them in Germany, get them packaged in France, assembled in Poland, and maybe launched from the UK or Norway one day is very cool. And at SPHERICAL, we have quite a lot of momentum. So we have commercial customers that have bought our systems to power their satellites, multiple commercial contracts with the European Space Agency. And personally, I'm quite happy to prove that you can make a commercial company, commercial chips, with open source tools. And for me, I want to see more and more companies do this. To finally finish off, we're based in Rotterdam, in the Netherlands, 25 people. but we have a lot of exciting projects coming up. So we are constantly hiring, constantly looking for people for new ways to design microchips. So if you want to come and design microchips for space, then definitely approach me and I'm happy to talk. Thank you.
Hi, thanks for the talk. I was just wondering, do you have any problems with open source tools, and like what's, like if there are bugs or missing features, how do you deal with that, and like why do you use open source sometimes and not commercial tools? Like what's the motivation to do the extra work and maybe be limited in some ways?
Yeah, so there are some gaps. I mean, let's say fab support of DRC LBS is absolutely pivotal for us. We want to see more of that, and hopefully XFAB will support K-layout DRC one day. We want to try and push them in that direction. The reason we use open source tools is it's more than trying to save money on licenses. It's about trying to focus on a new way to design chips rather than being pushed down the kind of use models that a lot of the big EDA vendors try and make them do. So it's kind of, we wanted to start from the scratch and build up the flow that really works for us to be much more competitive in how we can design these chips.
Great work. Was it just that you do software configuration and the chips that you have, is it like commercial off-the-shelf chips? You mentioned, for example, this gallium nitride process. Is it like these 400 degree PDK, or what is the technology there, and what are you using and what are you building on the hardware side?
Yeah, so it's a little bit of a novel business model because the things that we sell is literally like metal boxes like this. If I go back, sorry. Here. So this is the product. It's not actually our product, it's a competitor's product. But we sell the metal boxes like this with the electronics, so the PCBs, and the chips that we design. So it's very much a vertically integrated model. And then we design our own chips in-house. We use XFAB technology for the chips we design, and then we use external gallium nitride FETs. Hopefully that answers your question.
Hello. Yeah, basically the last question somehow anticipated what I was asking you. Since you mentioned that your whole chain is in Europe based, so the manufacturing too, and since space requires some special technology nodes like SOI or something like that, do we have these capabilities here in Europe to accommodate for such needs?
Yes, so we use an SOI technology from XFAB. And there's others like ST Micro as well has similar technology. Global Foundries 22FDX is in Dresden, I believe. So for sure there is the technology here on Europe.
Here in Europe. Okay.
Yeah.
Thanks.
Do you use aging models or aging sensors? And if yes, then which open source simulator support this?
No, we don't at the moment. We want to, but we don't know of any open source tools that can support it, so we use AFS there. But we really want to have more support there. So if you know anything there that we can work on, I'd be happy to talk.
Okay. Yeah. At IHP we have aging sensors. They are not for open source right now, but it's just heads up.
Yep. Okay. Cool. Very cool.
You probably won't have that large number of chips that you produce. Do you get along with multi-project wafer, or do you do a full run of chips?
So the first chip we did was a multi-project wafer, but we'll be moving on to MLMs, so multi-layer masks, and then you can get about 6 wafers, which is probably about perfect for us because then we can make, let's say, tens of units from those wafers, and then we'll just make another one with a new design. So it's a really nice sweet spot.
Okay. Thanks.
Can you describe a little bit more about the K-layout flow? Is it like manually drawn by hand, or are you using any Python or macros?
So at the moment it's manually drawn by hand with P-cells from PDK Master by staff, but we are actively investigating how we can do more automation there, so yeah.
Awesome. Let's thank Thomas again.
Thank you.